Okay, I am starting this discussion in section 9.2, which discusses payback period and discounted payback period. I'm just going to briefly address the question of a payback period, but I'm really interested in just setting up the examples that we use here. So this setup is that we've got a copier company, and they have a choice between two $5,000 machines, and they can only buy one of them. And so how do they make a choice between these two machines? And here are the cash flows associated with each of the machines, right? So in both cases, we have a $5,000 initial investment, and copier A has consistent cash flows over the 5-year time horizon of $2,500 incremental cash flow every year. Okay, and copier B has cash flows that start lower. They start at $1,500, then in the second year it's $2,500, and in the third year it's $3,500, $4,500, and $5,500. So if you think about how long it takes you to recoup your investment of $5,000, right? In the case of copier A here, it only takes 2 years, and at the end of 2 years, we have made back our initial investment of $5,000. So it only takes 2 years. Copier B takes a little longer than that, right? It takes somewhere, 2.5 years or so. Okay, so strictly from the question of the amount of time that it takes to pay back your initial investment, copier A looks like a better investment. But we can see even just from eyeballing this that over this 5-year life, right, these cash flows add up to a lot more money. And so the question is the fact that these cash flows adding up to a lot more money, is it relevant to our decision? Well, I would certainly think so, right? But because we know that this $5,500 5 years into the future is not the same as $5,500 today, right? We know that from our time value of money knowledge that we've developed over the course of this class, right? We have to find a way to do apples to apples comparisons between two different projects that have cash flows that are timed out differently. And the way that we do that is with a model called the net present value. Okay. So the net present value, as they state in your book, it is one of the single most important models in finance. Okay. And it's not only found in finance. If you go into public policy and you have to do cost-benefit analysis, right, you use a net present value model for that as well. So net present value is incredibly important, and this mathematical formulation here, all this says is that the net present value of a project is equal to your negative initial cash flow plus the sum, right? That's what all these are, plus, 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 the sum of all the discounted cash flows associated with that project. And because you are choosing an appropriate discount rate, your cost of capital, right? Because you are choosing an appropriate appropriate discount rate, then you will accept a project if it has a net present value of greater than 0. You will accept a project that has a net present value of 1 penny. Because the discount rate, your cost of capital, is the money at which you are expecting to be able to invest any of your cash. And so if you have your own project, you invest it in that. If this project can't meet your required rate of return for any of your investments, then you go invest in something else. Right, so if we look at those two other copiers, remember we had copier A, which had these first cash flows of $2,500 in the first couple of years, so it had a payback period of 2 years. Well, if you discount all of these cash flows at a 6% discount rate, you wind up with a net present value of $5,500 positive. So that looks like a good investment. Okay. And then if you look at the cash flows from that copier B, right? Because our cash flows, were much greater in outlying years, we do discount this $5,500 cash flow by 5 years, but even so, we wind up with a net present value of $9,200. So copier B has a greater net present value. Now, both of them have a greater than 0 net present value. But if you can only buy one copier, you buy the one with a higher net present value. It's a better investment. Now, the next subsection of section 9.3 talks about the idea of mutually exclusive projects versus independent projects. So, first of all, the decision criteria says that if a project has a net present value greater than 0, then go ahead and take it on. Well, okay. If all of your projects are independent, right? If they don't rely on the same resources and you can pay for them all, well, sure, go ahead. Get rich. But that's not necessarily how things work in the real world, right? So, many projects in the real world are mutually exclusive. If, you have 2 different projects that fill one need, for instance, that copier example, right? You only need one more copier. Which one are you going to pick? Or the other thing that can make 2 projects mutually exclusive is that that there's a scarce resource that both projects need. Right? So if you have one piece of land, you can only put one item on it, one factory, one power plant, one farm field or whatever, then, you can only do one. All right? The other thing is, the scarcest of all resources, of course, is capital constraints. And so, all companies have capital constraints. And you can only take on as many projects as you can afford to do. Even if they're going to be profitable, you still don't have unlimited fundraising capacity. Okay? But when you have to make decisions between projects, the one that you choose is the one that will give you the most bang for your buck, right? The greatest net present value. Okay? The other issue when you're looking at choosing between projects in a capital constrained situation is not all projects have the same life. Right, and so there's some manipulation that you need to do to be able to compare apples to apples when projects have different lives, different expected lives. And so I have you do an example of this in the spreadsheet homework, and it might actually be easier for you to just skip over to the practice problems than to listen to my explanation for it, but I'll give the explanation a try. There's a couple of different options that you can do. One of the things that you can do is sort of multiply out the cash flows and until you've got a point where, you've got the least common multiple. And then compare, let's say you've got a 4-year project and a 5-year project. And so you'd multiply them out to a 20-year project, and then you can compare them that way. That's not ideal, right? Definitely not ideal. It's always better to have a mathematic solution that actually reflects reality, right? So the second thing that you do is to find what's called the equivalent annual annuity, the EAA. And the way that works is you take the project's net present value, and using the appropriate discount rate for the project and the life of the project, you find the annuity stream that equates to the net present value. Okay, so what that turns out to be, here's the formula for it, right? So the present value factor of an annuity, which was discussed in one of the earlier chapters about the time value of money, it's defined as 1 minus 1 over 1 plus r to the n divided by r, right? And I show you how to do this in Excel. And so then your equivalent annuity, your equivalent annual annuity, is the net present value over this factor. Okay, so that, you know, probably won't make a lot of sense until you go and do it. Go to my practice problems and give it a shot. And so that's pretty much it for the technicalities of how to calculate net present value. Okay, so you've got a few examples of how to do it. It's an incredibly important financial model, and we will return with the IRR in the next video.